Good morning, you're welcome to today's class. Clifford, you're welcome. Osako, you're welcome. Duka Favor. Golden, good morning. How are you today? Dimpolite, you're welcome. Osako, you're welcome. Waec, you're welcome. All right. Let me set my poll. All right, so we're going to do a review on moments of a force. Good morning, students. Welcome to today's class. Today we're going to look at calculations on moments of a force. Okay, so we're going to dive into that with the explanation of moments, even though I've done it previously. But some of my students say they did not understand, so I need to come back and explain to them how to solve questions on moments of a force. Okay, now that is what we have on the board. Please, can you see the ends of these lines? Can you see the two lines on the board so that we can work with that? Please, can you see the two ends of the board? I gave two lines. Can you see the lines? Because I want to work with that so that all can see what I am doing. Are we together? Can't we? Who is online? Can we please? So we can proceed. Light, peculiar, Clifford. All right. Sorry, my messages was hidden. I just said, Veronica, you're here. Welcome. Clifford, okay. You're welcome. So let's proceed with what we have today. Okay, Osako, you're not seeing the right hand side of the board. Okay, let me adjust. Is it okay now, Osako? Can you see the two lines on the board? Can you see that? Osako Kichibu, can you see that? Sylvester, you're welcome. JOF001, you're welcome. Okay. Maruchi, you're welcome. Osako, can you see the two lines on the board, please? So we can proceed. Shift a little Constant, you're welcome. It's fine now. Okay, so we can start. Thank you so much. All right. Previously, we did the moment of a force, and we defined moment as the product of force and its perpendicular distance. Okay. Now, how do I explain that? Let me use an illustration to explain what is moment and how we can calculate moment. Right. Now, this is a meter rule. This is a meter rule, and this is a half of a meter rule. Okay. If I hang a force here, that is the perpendicular force, force acting down rather. Now, and this is where the center of the meter rule is. From here to the center, that becomes my distance. From where the force was hung to the center, that becomes my distance. So how do I calculate moment there? Moment is equals to the force times the perpendicular what? Distance. Force multiplied by perpendicular distance. That is, moment is equals to force times distance. Okay? Now, let me talk about the units of moment. Unit is equals to unit of m is what? Force is measured in Newton, distance is measured in meters. Okay? Now, the unit of moment is Newton meter. Alright? Now, we can also get the dimension of moment. Why I always refer to know the dimension is this, because you will see it in an external exam. So you're supposed to get used to what? Dimensions of physical quantities. Okay? Alright, so if I say dimension of m, remember that Newton is a force. Our unit of force is also the same thing as kilogram meters per second square. So I can just say by kilogram meter per second square times meter. Using the law of indices, this one have power of 1 power of. I'm going to bring them together by saying kilogram meter square per second square. Kilogram meter has power of 1. I bring them together to give me meter square per second square. This is the unit of force. Now, for me to get the real dimension of force, kilogram is for mass. Okay? Dimension of m. Kilogram is for mass. We're going to write what? Capital what? M. Meter is for length. We write capital L. Power what? 2. Okay? Then seconds is for time. We write capital T. Power minus what? 2. Do we understand? So this becomes what? The dimension of moment. This becomes the dimension of moment. And this unit and dimension of moment is the same thing as work, because work is defined as the force and what? And the distance in which the force took place. So going by that, the unit of moment is equals to kilogram meter square per second square, or the dimension is what? ml squared t minus 2. Do we understand? So this is what we have under moment, the unit and the dimension. So we are going to look at clockwise and anti-clockwise moments. Okay? Right. All right, copy what you have on the board. Let's proceed. Are we done? You worry, Francisca, you're welcome. Onyema Grace, you're welcome. Please give it a thumbs up, okay? All right, Blossom Kenneth, you're welcome. Dimpa done, Clifford done, right? So let's proceed. Waec. Thank you so much. Please give it a thumbs up, okay? Okay, thank you so much for that. Please give it a thumbs up, okay? All right, so let's proceed. All right, we're going to look into clockwise, and anti-clockwise moment. Clockwise and anti-clockwise moment. I will explain with an illustration. Now we have this body. Okay, let me use one. This is 20 Newton, while this is 50 Newton. This should be in the middle for it to balance. All right. Now the distance from here to here, the distance from here to here is B, while the distance from here to here is A. The question is, what is my clockwise moment? What is my anti-clockwise moment? When we are making respect to clockwise and anti-clockwise, you know the direction of your clock. Your clock goes this way, right? Your clock moves this way, right? So if you consider this direction, this becomes clockwise moment. Do we understand? This is the direction of your clock. If you consider this direction, this is what? Clockwise moment. But if you consider opposite of it, this becomes what? Anti-clockwise moment. Do we get it? All right, and we are considering from where the point, the force was hung to the center. We are considering from where the force was hung to the what? To the center of the pivot. Do we understand? I will explain further on that. Now, remember that moment is equals to the force and the perpendicular distance, okay? All right. So this is clockwise moment, while this is what? Anti-clockwise what? Moment. Then going by that, what is my clockwise moment? Clockwise moment is equals to what? 60 times what? B. From here to here is what? B. That is my clockwise moment. So that is 60 times B, which will give me 60B, right? My anti-clockwise moment, that is 20 times what? A. From this point to the center, the distance is A. So I will have anti-clockwise moment to be what? 20 times what? A, which is what? 20A. Do we get it? So that is my clockwise and anti-clockwise moment. Okay? From the principle of moments of forces, the clockwise moment equals what? Anti-clockwise moment. Do we understand? That's if two bodies are in equilibrium, then the clockwise moment is equals to what? Anti-clockwise moment. If going by that means clockwise moment is equal to what? Anti-clockwise moment. That is 60B is equal to what? 20A. Do we understand? Clockwise moment equals anti-clockwise moment. That is 60B is equal to what? 20A. That is from the principle of moment of forces. Is that clear? Right. Sylvester, you're welcome. Just put it down. Put it down, put it down. Let's proceed. So, Kokeshku, thank you so much. Ejapa, Onyeka, thank you for coming. Really appreciate. Please, are we done? Clifford done. Nduka done. Francisca done. All right, done. Done. Nduka done. Okay. All right, let's proceed. All right, copy what you have on the board. Obijiru, you're welcome. Okay, done. Sylvester, done, okay? Clifford, done. So let's explain. All right, the principle of moment says that if a body is in equilibrium, then the sum of the clockwise moments about any point on the body is equal to the sum of the anti-clockwise moments about the same point. Okay? If a body is in equilibrium, equilibrium means if the body is balanced, that means it's in equilibrium. Okay? Then the sum of the clockwise moments about any point on the body is equal to the sum of the anti-clockwise moments about the same point. So, by the illustration I gave you, I have this. If this body is in equilibrium, that means the body is balanced. Balanced on this knife edge. This is called knife edge or pivot, right? Now, if the forces, this is F1, why this is what? F2, right? And the distance separating them is what? A. Distance separating this one is what? B. Okay? If this bench or this ruler is balanced on this knife edge, then the sum of the clockwise moment, if they say the sum, you know why the sum is there? The sum of the clockwise moment, it means there's a situation we can have more than two moments at the same time, okay? We can still have another one here. This is still what? Clockwise. And the distance from here to here is what? C. Are you getting it? The sum of the clockwise moment, there's a possibility that you may not have just one of the clockwise now. This one is clockwise to this, while this one is also what? Clockwise to this. So this is clockwise moment, okay? It's equal to the sum of the anti-clockwise moments. You can still have another one here. I'll tag it F4. And the distance from here to here, I'll call it what? D. This becomes what? Anti-clockwise moment. This becomes what? Anti-clockwise moment. Do you understand what I'm explaining? There's a possibility you have you have more than one, and they are clockwise moments. This one too is clockwise. Coming to this is what? Anti-clockwise. This is what? Anti-clockwise. And now, your clockwise moment must not exceed the center of this pivot. Once it crosses here, it's no longer clockwise moment. It's going to be clockwise up. That is in this direction. It becomes clockwise again. That's once you reach here, it's going to start the rotation from here. That's still clockwise, okay? Then anti-clockwise, once it passes this center where the body was balanced, it's going to be anti-clockwise here. That is here. Anti-clockwise. Okay? Why this side is what? Clockwise. What am I trying to say? We'll have positive and negative moments. But then, if you have two moments this way, this is clockwise, this is clockwise. We are making respect to the center, which is the pivot or the knife edge. Now, this is anti-clockwise, this is anti-clockwise, okay? Then I said that if this clockwise will exceed here, it's going to continue to be clockwise from here up. If this anti-clockwise should exceed this center, it's going to continue to be anti-clockwise from here. I don't know if you understand what I explained. Right. All right, copy what you have on the board. Grace done, Veronica done, Francisca done, Obijiru done, Nduka Favor done. Omojo done, okay? Asafe done. Please make sure you subscribe if you have not subscribed to this channel. Obijiru, are you done? Kenneth, I don't understand from F4. Okay. Let me go back and explain so you can understand. Now, this F4 is anti-clockwise. I said it is sum of the clockwise and the sum of the anti-clockwise. There's a possibility that you may not have only one moment on this side or on this side, okay? But because it is facing this way, it is going this way, it becomes what? Anti-clockwise. This is still anti-clockwise. And the anti-clockwise will end here once the body crosses this pivot. Okay? It's going to continue this anti-clockwise from this side up. Why this one will continue from this? Okay, don't worry. After this, I'm going to explain it again with a bigger diagram so you can understand better. Odiba, you're welcome. How are you today? Matilda, you're welcome. Please give it a thumbs up if you're just joining us. And I hope you have subscribed to this channel. All right, so let's proceed. Secondus, you're welcome. Yakub Alam Short Phone, you're welcome. Thank you for coming. All right, copy what you have on the board, please. Are we done? Let me explain. Sylvester, are we done? Clifford, Blossom, Grace, are we done? Okay, Odiba done. Thank you, Alarm Shot Funny. You're welcome. Sylvester done, Grace done, Veronica done. Okay, let's explain. All right. Now, I want to explain this. This is under positive and negative moments. If you have positive and negative moments, how do we know how to resolve it? It was just what I was explaining the previous class. So let me expand this so I can understand it better, okay? Now, if you have this moment, this is F1, F2, F3, F4, and F5. Which one is clockwise? Which one is anti-clockwise? Following the way in which your clock rotates, it says to do what? Clockwise. Okay? If you go this direction, it's clockwise. But if you go this direction, is what? Anti-clockwise. So going this direction, F3 is clockwise with respect to what? To this pivot. This is the reaction acting up, right? Reaction of the weight acting up. F3 is clockwise moment. F4 is what? Clockwise moment. Okay? So we are resolving it. The distance is from here to here, while the distance of this is from here to here. Do we understand? Okay. So we go. This is what? Clockwise moment, right? Now F4 from here to here is what? Clockwise moment. This is what? Clockwise moment. Do you understand? Then for us to go to anti-clockwise, this is what? Anti-clockwise, because it's going this direction. This is anti-clockwise going this direction. So this is what? Anti-clockwise moment. Why this is what? Anti-clockwise moment. Do you understand? And I said that this clockwise or anti-clockwise, once it crosses this pivot, it's no longer going to be clockwise. It's going to continue from here up. Okay? Now for the diagram I have, this is anti-clockwise, this is anti-clockwise. So here is also what? Anti-what? Anti-clockwise moment. Do we understand? Because it's like a loop. Once it rotates and reaches, it's going to continue its rotation here. So for me to have clockwise, I can say that here is what? F what? 6. Here is F6. And the distance from here to the pivot, I will call it what? A6. So this is what? Clockwise moment. Do we understand? So once the clockwise crosses this midpoint, it's going to continue again from here to the what? Clockwise. And once anti-clockwise crosses this midpoint, it's going to continue from here to the what? Anti-clockwise. Do we get it now? Alright, so we said clockwise moment is equals to, remember that moment is the first and perpendicular distance. So this is F3, the distance from here to here is what? A3. So this is F3 dot what? A3 plus, this is F4, distance is what? A4 plus F4 dot what? A4, right? This is under clockwise moment. Now for us to do anti-clockwise moment, that is what? F1, distance is from here to here, right? A1. That is F1 dot what? A1 plus F2 dot what? A2. F2 is from here to here, right? Okay. All right. Then plus what again? This is what? Anti-clockwise. F3, F5 dot what? A5. Do you understand? Now I added this extra one to make it to balance the equation. Then this is what? This is what? Clockwise. I will now add this where we have clockwise plus F6 dot what? A6. Do you understand? So you add all the clockwise moment together and add all the anti-clockwise moment together. Then from the principle of moment, if the body is in equilibrium, then the sum of the clockwise must be equal to the what? The sum of the anti-clockwise. Okay? So clockwise moment must be equal to what? Anti-clockwise moment. Anti-clockwise moment. Then going by that, we have the clockwise moment to be what? To be F3 dot A3 plus F4 dot A4 plus F6 dot A6 is equals to F1 dot A1 plus F2 dot A2 plus F3 dot A3. Do you understand? Then this is equals to this, right? When you substitute the values you have, you can find your node, which is what you're looking for. Alright? Then if I carry these ones to the other side, I'm going to have positive and negative, and the sum of it is going to be equal to 0. Do you understand? And if I choose to do that, I'll say this is F3 dot A3 plus F4 dot A4 plus F6 dot A6 minus, I'm taking this one to this side, F1 dot A1 minus F2 dot A2 minus F3 dot A3 is equal to what? 0. Okay? So this is how we can resolve this positive and negative moments. So put it down, let's solve calculations on what we have done so far. Right. SHM means simple harmonic motion. Simple harmonic motion. No, Clifford. Waec. You can't see the down part. Can you see it now? Oh, my Grace. I should teach you simple harmonic motion tomorrow. All right. I made an error. Where, please? Okay. That's anti-clockwise moment. F5.A5. F5.A5. All right. Thank you for the observation. That means we are working together. Ethiopia First Tube, you're welcome. Thank you for joining. Please give it a thumbs up. Give it a thumbs up. Are we done writing? Umote Junior. Sorry, I don't know your name. You're welcome. Alalibo. You're welcome. Secondus. What's the question, please? Secondus, what's the question? Well, okay, this is a 2 hours class. It's ending by 1, past 1. You can't see the downside. I thought I've adjusted it. Amarachi Kenneth. I should explain the part where it becomes negative. Okay. Secondus. Yes, it's multiplication. When you say dot, dot means multiplication. Okay, the downside is blurring. Okay, let me rewrite it again so you can see. Is it okay now? Then light. You see that she explained why it's negative. You know that this is clockwise and this is what? Anti-clockwise. Now when I carry this clockwise to come over to this side, it becomes a negative what? Moment. Then it will not be equal to what? 0. It will not be equal to 0. So this is clockwise moment, this is anti-clockwise moment. Carrying this one to the other side, the sign will change to what? Positive and negative. So I have positive and negative moments, right? Then the sum of it will not be equal to 0. That's what I mean by positive and negative moments. Do you understand? Right. Amarachi Kenneth. If you are still with us, give it a thumbs up. Are we done? Let's solve problems. Chidi is not for SS1. SS1 is by 2 p.m. today. I'm going to do your holiday assignment, SS1. So get ready for that. The marker is becoming weak. Are we done? It says two holiday assignment is under simple harmonic motion. SS2 holiday assignment is under simple harmonic motion. It's theoretical part. Does not really have calculation. Clifford, your holiday assignment is what you can just get from textbook and put down and submit, okay? It does not really have calculation. But I can still teach you simple harmonic motion. That will be on Saturday live. Okay, class, are we done? Let's proceed. If you are just joining us, please give it a thumbs up, okay? Give it a thumbs up and like this live stream. Okay, I will teach you simple harmonic motion on Saturday, our normal time. Okay, some of them are not in the textbook, but you can check it online. You can check it online, you see it there. All right, so we are done. Odiba done. Okay, Grace, yes, I said so. Assignment and corrections on Saturdays, okay? I will do that. Being polite. As I teach you simple harmonic motion tomorrow, I may not be able to go live tomorrow, okay? I will not be around. All right, copy. Let's solve what is on the board. All right, look at this question. They say, what is the value of X? How can you solve this question? We have 50 kilograms hanging here. We have X kilogram. We have 15 kilograms. And they gave us different distances for them. Now we're going to use clockwise moment and anti-clockwise moment. From the principle of moment, we equate them together to find the unknown, okay? All right, so let's go. This is what? Clockwise moment. This is what? Clockwise moment, right? Why this is what? Anti-clockwise moment. So my clockwise moment is equal to what? This is X. The distance from here to the center of the pivot is what? 1.5. So that is X times 1.5, right? That is not just the only clockwise moment that we have. We now add it together. Plus, the second clockwise moment is 15. Multiply from here to here is what? 2. So I will say plus what? 15 times what? 2. Do we understand? Going by that, this time this is going to give me 1.5x, right? Plus 30. Is that okay? All right. So let's go. Anti-clockwise moment is equals to, this is 15 times from here to here is what? 1.5. Sorry, this is 50. From here to here is what? 1.5. So I'll go by saying 50 times 1.5, right? Okay, let's use our calculator to multiply and get our answer. So this is 50 times 1.5. I'm going to have 75. This is 75, right? Now, if clockwise moment is equal to what? Anti-clockwise moment. That is 1.5x plus 30 is equal to what? 75, right? Then I'll carry this to the other side. Then I have 1.5 is x equals to 75 minus 30. That will give me 45, right? 1.5x is equal to what? 45. So I divide one side by the coefficient of x, which is 1.5. I cancel. Therefore, this is going to give me x is equals to 45 over 1.5. X is equals to, let's find out. So my x is equal to what? 30 kilograms. Do you understand? Right. Obijiru, how will you know when it moves in clockwise and anti-clockwise direction? Okay. Clockwise and anti-clockwise direction. Now, Obijiru, if you see a vector on this side and you want to resolve it to go this direction is what? Clockwise. Okay? Now this is clockwise, and I told you that looking at a clock rotates this way. So this is clockwise direction. So from here, we are making respect to this pivot, which is the center of the meter rule or the bench in which the masses were hung. And before clockwise moments must be equal to anti-clockwise moments, the body must be in equilibrium. That means this bench must be balanced horizontally, okay, before we can talk about clockwise and anti-clockwise. So this is clockwise. From this force, making respect to this center, is going this way, is what? Clockwise. You know that moment is force and perpendicular distance. So the force here and the perpendicular distance becomes clockwise. The force here and perpendicular distance becomes clockwise. So from here is clockwise. The clockwise is ending here. Okay? This is another clockwise. Alright? But when you are taking it to this direction, this becomes what? Anti-clockwise. This one cannot go this direction. This 50 cannot go clockwise because there is no pivot you are making respect to. But we are making respect to this pivot, so this becomes clockwise, this becomes clockwise. Do you understand? So this is the way we can say clockwise and anti-clockwise moments. Right. Right, you're welcome. You don't have channel, they just came to learn, okay? Thank you for stopping by. Mandalin, you're welcome. Please, can we copy fast? We have a lot of things to discuss today. Secondus, I'm coming to your question. In the clockwise solving, why did you multiply 1.5 by x instead of multiplying x by 15? Okay, that's the first question. I got you. Odiba, you are done. Second is I'm coming to your question. Right, please, they are students. They don't compare with each other here, right? They just came to learn. All right, secondus. You say, why did I multiply 1.5 by what? X. Okay, is that your question? All right, because the distance, this is where this force was hung. And the distance from here to the center is 1.5. So this is distance for this x. Okay? That's what I said by this is x. This is the force. You know that moment is the force. Moment. Let me explain again here. This is moment. No, this is moment. Force at the particular distance. So from here, the force was hung to the distance, to the pivot. That is the distance we are considering. So we are making respect to it was hung is from here to here, right? And distance is 1.5 meters. Okay, second is I getting it. Then this is 15 kilogram. From here to where it was hung, the distance is what? 2 meters. Do you understand? So that is what I mean by clockwise. From here to the pivot, then 15 from here to the pivot. A distance from here to here is 2. The distance from here to here is what? 1.5. And that is why I multiply by that. Mandala, you don't understand. Okay, let me explain again. Mandala, don't cry. Let me go again. You know, if you are just coming, you might not really understand that I already explained this moment of a force before coming to this one. Okay? I said that this is a question given, and we are asked to resolve it to find the value of x. For us to get the value of x, from here, this is clockwise. What is clockwise? Clockwise is the direction. Clockwise is the direction of a clock going this way. Clock goes this way. Okay, that's the direction of a clock. So this is going this direction, and we are making respect to this pivot, which is the center, right? So from here to the center, I have a distance of 1.5 meters. From here to the center, I have a distance of 2 meters. So going by that, from here to the distance is 1.5. And if I'm resolving it, what is the moment? The moment is the force and the perpendicular distance. So the force here is x, even though we are looking for x. The distance from here to here is 1.5, okay? Plus this one, the force is what? 15. The distance from here to here is what? 2 meters, right? Okay, so the anti-clockwise moment is 50. Distance from here to here is what? 1.5. So we worked it out by saying x times from here to here is 1.5, okay? Plus 15 from here to here is what? 2. And that was 1.5x plus 30. Did we get it? Now, anti-clockwise moment is 50 multiplied from here to that is 1.5. I gave you 7.5. But from the principle of moment of forces, we said that clockwise moment is equal to what? Anti-clockwise moment. So going by that, what is my clockwise moment? 1.5x plus 30 is equal to 75, right? Okay, then I'm going to carry this 30 to the other side. So this is 1.5x is equal to 75 minus 30 to give me 45. I divide both sides by 1.5 to get the coefficient of, to get x. So I have x is equal to 45 minus 1.5 to give me what? 30 kilograms. Do you understand? Right. Okay, do I understand now? All right, that's good. All right, so can we proceed? Okay. Next question. All right. Copy what we have. Let's solve together. All right, can we copy what we have on the board? Clifford, Amajo, Grace, Weke, Oyema. Copy what we have on the board. Sylvester, done. Secondus, where are you? Oyema, done. Joanne, done. Clifford, are you done? Matilda, done. Magdalene, done. Alanibo, done. Asakwe, done. So let's proceed. A beam PQ pivoted at P carries a load of 80 Newton as shown below. Let me go again. A beam PQ pivoted at P carries a load of 80 Newton as shown below. Calculate the effort E, that is this, required to keep it horizontal. Let me say horizontally, okay? We are given this diagram. Now, how do we solve it? It looks as if it's not what we are discussing, but it is the same method we are going to use to solve it. That is clockwise and anti-clockwise moments. Okay? Now, look at it. We are making respect to this pivot. Our movement is to this pivot. We have a force of 80 Newton, but it's acting down. We have another force of E that is acting up. So we are asked to find the magnitude of the effort, which is E. What do we do? Looking at this 80 Newton in respect to this pivot, it becomes clockwise. This is clockwise moment, right? Looking at this E can no longer come this way to be clockwise. It's going to be anti-clockwise, but in this direction. Do you understand? This effort E cannot come this way to be clockwise. It's going to go up to meet these people. That means it is what? Anti-clockwise. I told you that we can have anti-clockwise up and still have clockwise down from positive and negative moments. With that being said, this becomes what? Anti-clockwise moment. Okay? Now, if this is anti-clockwise moment, we are making respect from here to here. The distance of this 80 Newton is from this to this, that is 0.5 meters. Whereas the distance of this E, which is the effort, is from here to the pivot. So I'm going to add 2.5 plus 0.5 to give me the total distance. Okay? With that being said, let's go into, we say clockwise moment is equal to 80 times what? 0.5. That's 80 times 0.5. What do we have? I will have 40, right? Anti-clockwise moment, that is what? E times from here to here. I will say in bracket 2.5. 2.5 plus 0.5, right? This is going to give me 3. So it's equal to 3 what? E, right? Then if clockwise moment is equal to anti-clockwise moment, that is 40 is equal to 3E. We divide both sides by coefficient of E, which is 3. Okay? Therefore, E is equal to 40 divided by what? by 3. Okay? With our calculator, 40 divided by 3 is going to give me 13.333 what? Newtons. Did we get it? Right. All right, Mandalin, how will you determine if it is clockwise or anti-clockwise? You can get it with making respect to the pivot. The pivot is the center where you are concentrating, or that is the center of the pivot. The pivot is the center of your concentration, rather. This is where you concentrate to make your movement, because if you put a bench must be balanced. That means it is in equilibrium. So we are making respect of this to take our rotation. So making respect to this becomes clockwise to this. Okay? Now this can no longer be clockwise to this, but it's going to go back to be what? Anti-clockwise. So from here to here, this is clockwise to this, while this is what? Anti-clockwise. Okay. Omojo, are you done? Sylvester done? Iwori done? Grace done? Are we done, class? Okay, understand. Okay, done. Okay, Kenneth, you understand, okay? Look at done. All right, let's copy the question so you can solve. Are we done writing? Please, I believe you know why you are here. If you are not ready, I will remove you. Please, be warned. All right, so let's solve together. All right, the question says, determine the magnitude of P in the diagram below. How do we get the magnitude of P? We understood this one. This is like that of the previous one we saw. Now, this is a weight, which is the fulcrum or the knife edge. This is the force of 40 Newton. This is the weight acting down, okay? But we have this P going this way. So it is resolved at an angle 30 degrees. Include it, please. It is resolved at an angle of what? 30 degrees, okay? Now what do? We are asked to find the magnitude of P. How do we get the magnitude of P? This force P is supposed to act where? In the vertical direction. So we're going to resolve it in the vertical component. Remember, we have done scalars and vectors, okay? So for us to resolve it, we go this way. This is P. Vertical component is what? P sine what? Sine theta. Is that okay? The vertical component of this vector is P sine theta. And this is what we are going to be using to solve this. Do you understand? Because it is resolved with an angle. We have to resolve it to the vertical. Okay? Now going back clockwise and anti-clockwise moments, this is clockwise with respect to this knife edge. So I'll go this way. This is clockwise moment. Okay? Why this one will be what? Anti-clockwise moment. And the distance from here to the pivot is 20 centimeters. Whereas the distance from here to here is 50 centimeters. So with that being said, we now say that what? Our clockwise moment is equals to 40 times 20. Remember, you'll be like, why are we not converting this centimeter to meter? I choose not to convert because they have the same units. It's going to cancel out at the end of the day. But if in a situation whereby they have different units, you're going to do what? You're going to convert it and make sure it has the same unit before you start your calculation. Now this is going to give me 800. Okay? Then anti-clockwise moment. That is P sine theta. The distance is from here to here, okay? That is P sine. My theta is what? 30. Then bracket 30 plus what? 20. Do you understand? Okay. So this is P sine 30 is what? 0.5. 0.5 times 30 plus 20 is going to give me 50. Okay? By the time you multiply out, you are going to get what? 25p. Do you understand? Then, if clockwise moment is equals to anti-clockwise moment, that means 800 is equals to 25p, right? Then I divide both sides by what? 25. 25. This cancel out. So my P is equals to 800 over what? 25. Right? Okay. With the help of calculator, you say 800 divided by 25, and my answer becomes 32 Newton. Do we understand? Right. understand what I have on the board? If you do, put it down. All right, put it down, Sylvester. Blossom say you did not get it. Okay, let me explain for Blossom. Look at this. They gave us this P and they gave us the angle, incline. Okay? And we need to resolve it to the vertical component of it so that we can take it as anti-clockwise moments. Okay? So what I did was, remember scalars and vectors. To resolve a vertical component, it is what? P sine what? Sine theta. Okay? Then that is P sine theta, and sine theta is what? 30. That is anti-clockwise moment because it's going from here to the pivot. And the distance from here to here, this is 30 plus what? 20. Because the force is here now. We are considering from here to here. That is 30 plus 20. Okay? Now this is P times sine 30 is 0.5 multiplied by 30 plus 20 is what? 50. By the time you multiply, it's going to give you 25. That is 25p. Okay? Then for the principle of moment, if clockwise moment equals anti-clockwise moment, that means 800, which is what we have as clockwise, is equals to 25p. Then dividing constant by the coefficient of p, which is 25. Now, my p is equals to 800 divided by 25 to give me 32 Newton. Kenneth, do you understand better now? Right. Kenneth, is it clear? If you are just joining us, give it a thumbs up, okay? If you have not subscribed, just click on the subscribe button right now. Okay, you understand, okay? So let's proceed. All right. Copy what you have on the board. Are we done? Are we done, please? Odiba done? Sylvester done? Second is done. Alalibo done. Obijiru done. Kenneth done. So let's proceed. Lights done. All right, looking at measurements of weight of an object by the principle of moment. Measurement of weight of an object by the principle of moment. We want to use the principle of moment to measure the weight of an object, okay? We can measure the weight of an object, use example, a meter rule, using the principle of moment. We first find the rough position of the center of gravity, G, of the ruler by balancing it horizontally. Let me read it again before I explain. We can measure the weight of an object, example, a meter rule, using the principle of moment. We first find the rough position of the center of gravity, G, of the ruler by balancing it horizontally. What do I mean? This is a meter rule, okay? That is from A to what? D. Note that it ranges from 0 to 100. Now, how do we measure the what? The weight of this meter rule? This one, we are using a rough position of the center of gravity. You know what is a rough position? Let's assume this is 50. A meter ranges from 0 to what? 100, okay? And the middle is supposed to be what? 50. Is it not? That is where our pivot is supposed to be placed. So it will be balanced horizontally. But in this aspect now, the pivot will be placed either after 50 centimeter, which is the midpoint, or before 50 centimeter. Do you understand? The question will be asked in such a way that this pivot will be placed either 50 centimeter, either before 50 or after 50. We will now be asked to find the weight or the mass of the meter rule. How do we do that? Because we have already known, let's assume it is placed here at 60 centimeter. And you're asked to find the weight of the meter rule. We already know that the center of the meter rule is supposed to be what? 50. So you're going to place the mass here, or the weight, to get what you're looking for. That is what we are talking about. Using the measurement of weight by the principle of what? Moment. We can get the weight of a ruler, or weight of any bench, or weight of anything using the principle of moment by making it a rough estimate, using a rough position of the center of CG. We already know that center of CG of a meter rule is 50, because meter rule is from 0 to 100. Now we are using a rough estimate. Instead of using 50, we are now using 60, or even using less than 50 as the center of gravity. Do you understand? Now the purpose of that is that we want to place the weight of the meter rule at the rightful center, which is supposed to be what? 50. That is what you're trying to tell us. Okay? Now this is AD. This is the rightful center of the meter rule. But we now decide to place it here. So you can find the what? The mass or the weight of the meter rule. Then in finding the weight of the meter rule, they are going to place it at the rightful center of the meter rule, which is what? 50. Okay? So I'm going to bring examples for you to understand. I've done it before, but some of you said you don't understand. So I'm saying let me come again and explain it further the way you understand. So let's use an example to explain what I mean by this concept. Right. Ojiri, what is D? D is just an alphabet or a letter, okay? That is a letter. I just use it to explain that. All right, let's go to the next one. Yes, my dear, it's raining. Sylvester, it's raining. All right, copy what you have on the board. Are we done? Are we done? Omajo done? Odiba done? Second is no, okay. All right, let's explain. Example 1. A uniform meter rule balances on a knife edge at the 55 centimeters mark when a mass of 40 grams is hung from the 95 centimeter mark. Find the weight of the ruler. Let me go again. A uniform meter rule balances on a knife edge at the 55 centimeter mark when a mass of 40 grams is hung from the 95 centimeter mark. Find the weight of the ruler. For us to solve this, we are going to say, this is the ruler, and the ruler ranges from 0 to 100 centimeters. Okay? Now, the knife edge balances at the what? 55 centimeter mark. Now, this is my 55 centimeter mark. Do you understand? When a force of 40 grams is hung from the 95 centimeter, that is 95. That will be 95. And the 5 is what? The force is 40 grams. Right? What is the weight of the ruler? Now, you should know that a meter rule ranges from 0 to 100. And the weight of it, or the balance point of this ruler, will be at 50. So for us to get the weight of this ruler, we are going to place the weight at the main balance point, which is what? 50. Do you understand? Right. Now, following clockwise and anti-clockwise moments. This is clockwise, this is anti-clockwise, okay? This is clockwise moment. Why this is what? Anti-clockwise moment, okay? The distance from here to here is what? 40, right? And the distance from here to here is what? 5. 40 centimeter and 5 centimeter. Do you understand? Then going by that, my clockwise moment is equals to 40 times what? 40. Okay? It's going to give me 1,600, right? My anti-clockwise moment, that is m times what? 5. It's going to give me 5 what? 5m, right? Then if clockwise equals anti-clockwise, that is okay. We divide one side by what? We cancel. So this is m is equals to 1,600 over what? 5. What do we have? This is our calculator. I have 32 what? Grams. But we are asked to find the weight and not the mass. So we go by saying that weight is equal to what? Mg, right? But my mass is in gram. I'll convert it to kilogram by dividing by 1,000, okay? And my G is constant. So I will say weight is equal to 320 over 1,000 times what? 10, right? If this cancel this and this cancel this, right? 32 divided by 10, my answer is equal to what? 3.2 Newton. Do you understand? Right. Oh yeah, my Grace. Please, I don't want that discussion here. That is not why you are here. Please stop it immediately. That is not why you are here. I don't want that discussion. I don't want that discussion. Stop it right away because I'll remove you right now if you are not serious. What's the question secondaries? Maybe it has gone up. $50. Why is 50 there? Okay, 50 is the balance point of a meter rule. I have to put it there myself so I can be able to get the weight of the meter rule. Okay, I told you that the weight of the meter rule will be asked for you to calculate it. We are supposed to use the midpoint to get the weight of the meter rule. But in such question like this, normally they will give you a pivot at either less than the center of gravity or greater than the center of gravity. Okay, now going by that, we are asked to find the weight of the ruler. How do you find the weight of the ruler? You can find the weight of the ruler by placing it at the rightful position of the center of the meter rule. And that is why I place 50 there. Because the center of a meter rule, which ranges from 0 to 100, is 50. Okay? But the knife edge was placed at 55 centimeters. Now, how do we calculate it? We are going to place the mass of the ruler at the rightful center of the ruler, which is 50 centimeters. Okay? And that is why we have 50 there. You understand? Okay. Are we done? For the G, okay, that is the approximate value of G. Yes, I choose to use G as 10, okay? In some cases, they will give you G as 9.8, but the approximate value of G is 10 meters per second square. All right, so let's solve another question. Now, see if you can attempt this question. You just have a few minutes to do that. I hope you are solving. It depends on the question. Balance on a fulcrum. Balance on a fulcrum. Fulcrum is something as knife edge. Okay, lights. If they say meter rule, that means a meter rule ranges from 0 to 100 and the half must be 50. Okay? But if they say half meter rule, that means it ranges from 0 to 50. The midpoint will now be what? The midpoint will now be 25. Okay? All right, just try. I have a few minutes to do that. I will solve. We are almost coming to the end of this class. Your answer is 280 grams, okay? William Grace, the answer is 200 grams, okay? Mandali, your answer is 280 grams. Where did you get 10 times 10? Times 10 from? Okay, maybe when I multiply by the gravity, because I was asked to find the weight at that particular question. On that particular question, sorry, I was asked to find the weight. Also, I multiply by 10. All right, Omojo, I got 280 grams, okay? Okay, let's we got 200. Sylvester, I got 200. Odiba, I got 200. Okay, Secondus, you got 200. Okay, Sylvester, I got 280. You said 280. Yes. Okay, Kenneth, your answer is 200. We cross check, okay? Obijiri, you got 200. All right, let's solve together to see who is actually correct, okay? All right, let's go. A uniform meter rule is balanced on a knife edge placed at 35 centimeter mark. Now, once you see a uniform meter rule, it means a meter rule that is balanced, that balances on a 35 cm mark. Okay, so from this is a meter rule, ranges from 0 to what? To 100 centimeter. Now, this pivot or the fork rule was balanced on the 35 centimeter. Okay, by suspending a mass of 120 grams at the 10 centimeter mark. This is 10 centimeter mark and a mass of what? 120 grams, right? Calculate the mass of the meter rule. Now, how do we get the mass of the meter rule? Knowing that the meter rule has this center at 50 centimeter, okay? We are going to place the mass at 50 centimeter. So we place it at 50 centimeter. Do we understand? So the distance from here to here, 50 minus 35 is 15. Okay? 35 minus 10 is 25. Do we understand? Now, clockwise moment is equal to m times 15. Okay? That will give me 15m. Right? Anticlockwise moment is 120 times 25. Okay? That will give me what? That will give me 3,000, right? In clockwise moment is equals to anti-clockwise moment. That means that 15m is equals to 3,000, right? I divide both sides by 15. 15. Okay? So I have my m is equals to 3,000 divided by what? 15. So my answer will be what? 200 grams. So our answer to this question is 200 grams. So if your answer is 200 grams, you are actually what? Correct. Right. Do we understand? Do we understand? Mandela, I should explain again. All right. I said that this meter was pivoted. This fork means this pivot. They place it at 35 centimeter, and this is 35 centimeter. And the meter ranges from 0 to what? 100. But this 35 centimeter, this is not where you're supposed to put this pivot. Okay? But the essence of putting it is for us to get the weight or the mass of this meter rule. Now, when the mass of 120 is hung at 10 cm what? Mark, right? This is 10. We now have the mass of 120. Calculate the mass of the meter rule. How do you calculate the mass of the meter rule? From here to here, right? You are going to place the mass of the meter rule at the rightful center of what? Of gravity of that meter rule, which is what? 50. The center of gravity of meter rule is 50. So this is 50. To find the difference, 50 minus 35 is what? 15, okay? Then 35 minus 10 is what? 25. That is the distance from here to the pivot. Because we are making respect to the what? To the pivot, right? Okay. So clockwise moment is what? This is clockwise moment. This is what? Anti-clockwise moment. Clockwise moment is what? N times 15, that is 15n, is equals to 120 times 25, that is 3,000, okay? Then if clockwise moment equals anti-clockwise moment, that is 15n equals to 3,000, because I'm looking for the mass. And divide both sides by the coefficient of what? M, which is what? 15. 15, what do I have? N is equals to 3,000 over what? 15. By the time you divide it, the answer becomes what? 200 grams. Right. I think we are clear now. All right. So let me give you assignments for today so we can end today's class. Yes, we're going to hold online class on Saturday. We won't hold online class tomorrow because I will not be around, but I will send you a video that you watch. And take down your assignments. Are we done? You're welcome at Grace. Okay, you're welcome. Kenneth. Secondus. Okay, Odibadan. Look, Favor, you're welcome. Dimpadon. Some frat done, okay? Alalibo done. Omojo done. Obijiru done. No, I won't have class, live class tomorrow. I only have live class for SS3. But I won't have for SS2 and SS1. So I'll be live on Saturday. Veronica done. Sylvester done. Okay. Okay, that's good. Please like and subscribe. Okay. You can share it to your friends. Secondus, you're not seeing the board. Are you sure? Why not seeing the board? All right, give it a thumbs up and share it to your friends. It's blurry. Are you sure it's not from your network? Secondus. All right, class, we have come to the end of today's lesson. I hope you understood. Okay, make sure you do your assignment. And I told you earlier that the more you solve this, the more you know it better. Okay, see you next time in the next one. Bye. Okay.